Hi guys. So since the June exams are approaching for 2024, I'd like us to go through some revision of past papers. So this is taken from the June 2023, as you can see. I think it's the Eastern Cape paper. We're going to focus on this question 8 here. So let's jump right to it. Uh, we have a function which is a cubic function. We're given a cubic function of x cubed plus 4x squared minus 7x minus 10. Now we go straight to the questions. The first question, which is 8,1. Okay, let me decrease the thickness of my pen here. Oh, perfect. So the first question says write down the y-intercept of f. Now guys, in a cubic function, the value of c will always be your y-intercept. So basically here we are going to take out the value of c. In case you forgot the formula or the standard form of a cubic function, it is shown by y is equal to ax to the power of 3 plus bx to the power of 2 plus cx plus d. Oh, so my mistake. We are not looking for the value of c here. We are looking for the value of d. This will be your y-intercept. So to answer this question, you just write down that y is equal to negative 10. If you want to write it as coordinate form, you can say this is 0 is to negative 10. You still get your mark. Question 8.2. Show that 2 is a root of the equation fx is equal to 0 is a root. Show that 2 is a solution of the equation of f of x is equal to 0. So basically this is our f of x, which must be equal to 0. Now they say let us show that 2 is a root, meaning 2 is the value of x. This is what we're trying to prove. In order to do that, I'm going to write down the given equation, which is x cubed plus 4x squared minus 7x minus 10. Remember, we are trying to get 0. And then you go straight to substitute, meaning our x value is 2. I will say 2 cubed plus 4 times 2 to the power of 2 minus 7 times 2 minus 10. This must give us 0. If I bring calculator over there, so we've got 2 to the power of 3 plus 4 times 2 to the power of 2 minus 7 times 2, minus 7 times 2, so this is to the power of 1 and then minus 10. Okay, math error, let's see. Okay, there I made a mistake. My sign, I just fixed it just to double check if we get everything right. Okay, everything is fine. Now there is the answer. As you can see, this is going to give you 0, which is equal to 0. So all you had to do here was to substitute, and then this will equal to 0. You get your mark. Question 8.3. 8.3, hence factorize completely. They want us to factorize. I am going to use the synthetic method. Okay, so this is my f of x. F of x is given as x cubed plus 4x squared minus 7x minus 10. What happens here is, let me just get a bigger space. We're trying to factorize here. What happens is I'm going to draw an L facing that direction, and then I write the coefficients of my equation. Coefficient of x cubed is 1, positive 1, the coefficient of x squared is 4, the coefficient of x is -7, and then the constant number, which is 10. Now remember, we said that 2 is the root because it gives you 0 when you sub in there. Now what's going to happen is we are going to, let me change a pen to, let's take blue. What's going to happen is I'm going to bring down the 1 and then say 1 times 2, which will give you a 2. So we simply add the 2 to 4, which gives you 6, and then you say 6 multiplied by 2, which is 12, and then you say 12 minus 7, which is going to be 5. Then you say 5 times 2, which is a 10, and then 10 minus 10 is just 0. Now here, the last answer there must always be 0, guys. If it is not 0, you restart the process, okay? And then trying to factorize here, we have got now f of x is equal to, remember our 2 is a root, meaning 2 is a factor, so this becomes x minus 2. One may ask, why is it negative when we factorize, but it was positive there? Simply because if our x is equal to 2, when you bring it over, 2 becomes negative, okay? So we are only looking for that part, which is our factor. And then on the other bracket, I'm gonna take 1, 6, and 5, which will be the coefficients of a quadratic expression now. So it's x squared plus 6x plus 5, which I can factorize further. This is what I have. This is a trinomial. You open 2 brackets. My factors is going to be x and x. The factors of 5 is 5 and 1. The middle sign is positive. It goes to the bigger number. 5 is positive, meaning I need positive, so that 5 times 1 will give that positive 5. So our f of x is fully factorized. Okay, the next question, which is question 8.4. Question 8.4, let's see. It is further given that the coordinates of the turning points are approximately, they give us the coordinates of the turning point. Sorry about that. The first one is 0, 7 is 2, negative 12,6. The second one is negative 3, 4 is 2, 20,8. Draw a sketch of f. And label all intercepts and turning points. Something we must take from our factorized equation, guys, okay? We must take note that when we have factorized there, our x-intercepts will be x is equal to 2, x is equal to -5, and x is equal to -1. Now it's like you are solving for x from that equation, as you can see. And then remember, our y-intercept was -10, and then they gave us our turning points. So we basically have all the points that we need to plot to sketch the graph. Now I'm going to sketch my graph. I just need a bigger space. So to sketch this graph, firstly, Cartesian plane. So I'm going to try and be precise here. So this is my Cartesian plane. And then, okay, let me just try to extend it here. There you go. Now let us try to plot here. We have our first x-intercept as +2. So say this is 1, that means my +2 is gonna be there. Okay, I label it. and then -1. Say -1 is gonna be there. Then I label that -1 and then -5. So this would be -2, -3, -4, and -5. Then I label that. And then my y-intercept is 10, -10, sorry. -10 would be somewhere there, okay? This is -10. Then I label that. And then our turning points now. 0,7, which is somewhere here. 0,7 is to -12. My -12 can be there. So this is 0,7 is to -12,6. And then the next turning point is -3,4. So -3, 4, x, 4 somewhere there is to 20,8. Let's put 20 there. Then I write the coordinates. It's -3,4 is to 20,8. Okay, then what I'm left with now is to sketch the graph. You noticed our f of x, guys, has got a value of a that is positive, meaning this graph is an increasing graph. It is going to start by going up because the value of a was greater than 0. Now here is my graph. Here is my graph. Start by going up, turning point, back to the second x-intercept, to the y-intercept, to the turning point, then it goes up to the last x-intercept, and then I just try to elongate there. Now this is the graph of f of x. As you can see, I've shown every intercept and also I've shown the turning points. Then you get your marks. Let's see how many marks this was. This was 3 marks. Yes, 3 marks. You get your 3 marks. Question 8.4. Use your graph to determine the x values for which. Okay, now these are serious questions. 8,5,1. This is 8,5. Use your graph to determine the values of x for which the derivative is less than 0. The derivative of f. Now, the derivative of f, guys, we're going to use this graph. It's gonna get messy. Just bear with me. The derivative of f, please note that it is going to be a parabola. Okay? Now, my parabola will be in this form. Let me use different color. You see the x value of the turning point will become the x-intercept of my derivative. The turning point of the graph will become my derivative of the turning point. Okay, and then we have a point of inflection, which in this case we do not know what the point of inflection is, but note that the graph will be an increasing graph as well, facing up, concave up. So I'm not minding the turning point of the graph of the derivative. Say this is my derivative. Remember, this one is questionable. It's not your focus. So I've just drawn the derivative now of the cubic function. Let's see, go back to the question. So they said f prime, meaning the derivative is less than 0. They are asking for where the derivative is below your x-intercept. I mean x line, sorry. So as you can see, it is below right there. Okay, it is below right there. But what x values now? So the x values will be the x value here, which is negative 3,4, and the x value which is there, and that would be 0,7. That means x is between those 2 points. If you like, you can write it like this: x is an element of negative 3,4 all the way to 0,7. So this is your answer. I hope it makes perfect sense. Okay, I was trying to copy this, but I can't. Let me just go and write it. The answer here would be negative 3,4 x 0,7. Our x is greater but less than 0,7. Then we go to 8,5,2. Okay guys, 8.5.2 says we are looking for the x values whereby the gradient of a tangent to f, tangent, this will be a straight line, meaning it's the second derivative. Okay, the tangent of f will be a minimum. So let us find the second derivative. This was our f of x, which was x cubed. Okay, I forgot now, so let me go back to get the equation. X cubed plus 4x squared plus 4x squared minus 7x minus 10, just to confirm if we got it right. Yes. Okay, so we look for the second derivative. This will be the first derivative of x cubed is 3x squared, or 4x squared will be 8x and negative 7. The derivative of a constant number is 0. Don't have to write 0. And then when we do the second derivative, it will be 6x plus 8. Now you are going to equate your second derivative to 0. Okay, you equate your second derivative to 0, and then you start solving for x, because we want the x value. So this will be 6x plus 8 is equal to 0. If you solve for x, take a to the other side. When you divide by 6, which is the coefficient, you get negative 8 over 6, which can be simplified to negative 4 over 3. So this is your answer. This is the x value. This is the x value whereby the gradient of a tangent of f will be a minimum value. Okay, if you like, you can change it to a decimal number. Okay, and question number 8.5.3 is asking for the first derivative times the second derivative will be less or equal to 0. So the easiest way to find a solution here is to, okay, let me erase this red color here. The easiest way to find the answer is to take the first derivative, which is given as 3x squared plus 8x minus 7, and then you are going to multiply it with the second derivative as per the question. Second derivative, we solve it to be 6x plus 8. This is less or equal to 0. Okay, and then you get this inequality whereby you have to solve for x. When you solve for x, Okay, when you solve for x in this inequality and you do your number line, you are going to come up with a solution like this, which when you like, you can change the square root values to decimal numbers. So if you put this fraction negative root 37 minus 4 divided by 3, I'm sorry guys, I'm using my calculator here to try to be quick, then this would give you negative 3,36, which is basically 34, or included number negative 4 over 3 would be negative 1,33, recurring is 2, and then I'm just gonna remove the negative sign, and then you get 0,69, which is basically 0,7. So these are the x values for that. I know it's a lot of work for, oh no it's not, actually it's worth it guys. For 3 marks this is worth it. Okay, and these are your solutions. This is the revision of question 8 of last year's June paper. Please let me know which papers you'd like me, or which questions you'd like me to revise again. I'll make sure to post as soon as I can. Thank you so much.